Now it's my turn to ask you some questions. So I'm standing on top of a building which happens to be on a mystery planet somewhere in our solar system. I'm going to drop a cannonball off the top of the building, and the speed time graph for that cannonball is given by this. My question is, what planet am I on? What's my mystery planet? Okay, and also I want to know the distance the cannonball has traveled after 6 seconds. This is a straight line here. So we can imagine this as y equals mx plus c. Now I'm giving you that the gradient of this line is 11. Okay, so we can think of it as this: y equals 11x plus c. The reason why it's 11 is because if you look at this graph here, this point here is above 10, slightly above 10. It's not on 10. And see this point here is slightly above 10. This is slightly above 20. It's actually on 22. But you can't tell from my drawing. So that's why I'm giving you the gradient as 11. Okay. So now we can change the y to an s. S equals 11, or change the x to a t. So this graph is given by s equals 11t. Okay. So from this, my question is, hang on. My question is, let me just clear this up. So the equation of a straight line here is s equals 11t. Okay. My question is, what planet? Question one is, what planet am I on? And question two is, how far has the cannonball traveled after 6 seconds? And just a quick reminder: if there's an acceleration acting on this cannonball, the acceleration time graph will look like this. Okay, and the speed time graph will be a straight line like this, and the distance time graph will be a quadratic like this. It will be in the form of y equals blah 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 x squared. It will be something like this. Okay. Well, anyway, and remember the gradient of this, the gradient of the speed time graph will represent the acceleration. The gradient of this graph will represent the speed, and the area underneath the speed time graph represents the distance traveled. Okay, so of all the three graphs, always keep this inside your mind. This one's the most useful one, because from this you can work out the acceleration, and from this you can also work out the distance traveled. Okay, so this bit here is just a quick reminder, and also in a way it's a clue. So given this here, find out the distance. Well, find out what planet I'm on, and question two is the distance traveled after 6 seconds. So press pause. Before you do that, to answer question one, you have to use something from the graph, and then you might have to go away and look on the internet for the list of something of all the planets in our solar system. So you've got to extract something from this graph, and then you've got to go on the internet and look up a list of something of all the planets in our solar system in order to find out what planets I'm on. Okay, so well, anyway, press pause and have a go. What planet am I on? Okay, so if you look at this here, remember if we have the acceleration time graph, and then we've got the speed time graph, and then we've got the distance time graph, we've been given the speed time graph. So from this, work out the acceleration. So find the gradient of this. It will tell us the acceleration. You see, this is y equals mx plus c. M here is the gradient, which in this case represents the acceleration. So the acceleration is 11. So now you should have got, well, we know that the acceleration is 11. So if you bring up, if you go on the internet and look up what planet has an acceleration of 11 meters per second squared. Well, it turns out to be Neptune. So yeah, so you have to go away on the internet and look up all the gravity, all the gravitational pull of all the planets in our solar system. And then to answer question 2 here, you have to you have to find out the area underneath this speed time graph. And so here, you all you have to do is sketch it roughly. Speed time graph. It's a diagonal line like this. Now, because the question is saying after 6 seconds, so just sketch it. You don't actually need this. All you need is the equation. After 6 seconds, after 6 seconds, what is the y value here after 6 seconds? Well, put the 6 into here. It would be 66. Okay, it would be it will be 66, and the across here is 6. So it's a matter of getting the height times the width, and then divided by 2. So let's get 66 times 6, 66 times 6, and then later we can divide it by 2. Actually 66 times this divided by 2. So 66 times 6 divided by 2. I'm just going to merge these two together. So ultimately, it boils down to 66 times 3. So I'm just going to do 66 times 3. So this will be 18. Carry the 1. This will be 18. So it's 19. So this will be the distance traveled. I don't need to divide by 2 because I've used this 2 to merge it with the 6. So the distance traveled after 6 seconds is the area underneath this speed time graph, and the area here is 198. Okay, 198 what? Elephants, bananas, oranges, or what? Well, if you look at the up and down here, it's meters over second, and then you got to times it by this. Times it by this, so you're timesing it by seconds here. So this gets multiplied to the top. So it looks like m times s over s, which is a second. So these two kill off each other, and then that will give you meters. And then you got to remember you had to divide by 2, so you got to get meters divided by 2. Now 2 hasn't got a unit. Any number hasn't got. Numbers don't have units. So here you're just left with meters. So this thing here represents meters. So the overall answer is 198 meters. Okay?